The so-called triple point of water was never exceeded on Mars at either Viking landing site during the entire missions. So therefore the atmospheric pressure was always high enough to ensure that when the temperature rose above 0 degrees centigrade, which it did, that liquid water would form. Maybe just for a while, but microorganisms don't need long. But even beyond that, people wrote additional papers showing that liquid water forms in films in the tiny spaces between crystals of soil and even in the tiny spaces between crystals of ice. Enough for microorganisms. Indeed, in an experiment on the south pole of Earth, it was found that in ice that had never seen temperatures above minus 15 degrees centigrade, always been frozen, they found microorganisms living and metabolizing and reproducing. They were living between crystals of ice in the tiny films of water. Certainly, that could happen on Mars. I want to go back to the oxidant, the theoretical strong oxidant coating the surface of Mars. It was originally presumed to be hydrogen peroxide, but it turns out that several experiments looking for hydrogen peroxide in the atmosphere of Mars showed that there was essentially none there, far too little to have caused the results that we got. Now recently, something very extraordinary happened. The spacecraft Phoenix detected perchlorates in the soil of Mars. And scientists began to look at this and they said, hey, wait a minute, if there were perchlorates in Mars, the GCMS could not have worked to detect organic matter because the GCMS takes a soil sample and heats it to drive off vapors of organic matter that it then identifies. But if there were perchlorate in the soil at the Viking site, as there was at the Phoenix site, when the soil was heated, the perchlorates would explode and consume any organic matter in the soil. At about 300 degrees, perchlorates do suddenly decompose thermally and would destroy organic matter. Now, remember, in the label release experiment, the control was heated only to 160 degrees centigrade, and it was destroyed. So again, that couldn't have been perchlorates. But the presence of perchlorates could have vitiated the GCMS experiment. So it is now totally removed from the arguments against the label release having detected living microorganisms. Well, let's go back to summarize what the label release experiment found. In all, we ran 9 experiments, 4 experiment tests and 4 experiment controls. What we found was we got a response from soils that were heated to 10 degrees centigrade. That was the temperature we wanted to maintain to be sure that our nutrient would remain liquid, and that was a temperature experienced on the surface of Mars daily. So it didn't expose the organisms to any new feature in the environment. We found that if we heated the soil to less than 160 degrees, to 51 degrees, that we got a tiny response, 90% reduced from the initial response. In another experiment, when we heated the soil to only 46 degrees, the response was reduced by 70%. So here we had the kind of response to heat that you see with terrestrial microorganisms. If you want to distinguish between, let's say, the whole group of coliform organisms and the E. coli, the dangerous guys, you do this by incubating them 5 degrees apart. That separates them. The E. coli can withstand temperatures 5 degrees higher than the general band of coliform organisms. Very similar to what we saw on Mars. But then came what I think is a clincher. We wanted to do another experiment, but the engineers were afraid that we were now in winter and we might break the sampling arm by going out. So instead of going out, what we did was wait, in one instance, 3 months, and in the other instance, 5 months, holding the original active samples in the sample holders. We then tested them. And in each case, having held the sample in a dark box at 10 degrees centigrade, there were no responses after 3 months and 5 months. What kind of chemical reacts that way? We can't think of any, and neither can anyone else. We've asked them, and we've never had a positive response. But one could imagine that microorganisms taken out of their native environment and isolated from the daily cycle of light and dark, and not having any sunlight available, might readily have died. We looked in our library of responses, which we had accumulated prior to Viking, and there we found the answer also to the second injection. We found one Antarctic soil, and undoubtedly there are many, that when a second injection was made after an 8-day experiment, showed a reduction in the amount of gas that had already been evolved. It reacted the same, and you'll see a picture of that, as did the experiment with the second injection on Mars. So now we had answered all the questions. What could the remaining objections be? Well, I was trying to be conservative also. I didn't want to leap for that brass ring, which NASA said could be the most important experiment in the history of science. I didn't want to be wrong. So I studied the information of all the Viking experiments, all the new information that additional missions brought back from Mars, and also new information we were getting about life on Earth. We were all startled to learn that life is not a thin film delicately covering the surface of the Earth. Life is hardy. Even when the bomb goes off, we won't destroy the microorganisms that have gone into every niche on Earth. We have, since Viking, found life in the deepest parts that we have penetrated beneath the ocean, thousands of meters beneath the ocean, in the depths of the ocean, on clouds, on mountaintops. Any place you can name that has been sampled has produced extraordinary forms of living organisms at very high temperatures, at very low temperatures, so that it's hard to imagine an environment other than perhaps in molten rock where there would be no microorganisms. This opens up the possibilities for Mars greatly. In addition, we've learned much more about the environment of Mars, and we have found no single thing that would prevent the existence and activity of organisms on Mars. Even microorganisms we know on Earth could live on Mars, such as the ones down on the South Polar Cap. Well, with this new knowledge, I decided as a scientist it was my obligation that now having become convinced that we had detected life on Mars, to say so. And in 1997, I published a paper saying we had detected life on Mars. This was not received too valiantly. Many people strongly opposed it, even though they could not bring about strong arguments to the contrary.